Okay, today we're going to talk about quadratic expressions and equations. A quadratic is a shape that is an equation with a squared in it, and its shape is a parabola. So solving the quadratic equation, we're going to be using the square root property, we're going to be using completing the square, we're going to be using the quadratic formula, we're going to be using substitution of u when it gets over a quadratic. So all square roots have a positive, a primary root, and a negative, a square secondary root version of an answer. So when you're solving, you're going to get two versions, a plus and a minus, unless you're only working with the primary, which is a plus. And sometimes we will only work with the primary. Okay, solving a quadratic equation using the square root property. Steps. Isolate the square root by itself on one side. Square root both sides, remember a plus and minus version. Then isolate the variable and solve and verify the solutions that they work. Because sometimes the secondary, when put back in, won't work in specific situations, so you always have to check. So I'm going to pick up the 60 and move it over. I get 3x squared equals 60. I'm going to divide by 3. I still do not have the variable isolated. Now I do. I'm going to square root both sides. As soon as I put the square root on, a plus or minus is going to go on the front. Then this breaks into 4 and 5. 2 and 2. That means a 2 comes out with the square root of 5. So plus or minus 2 square root of 5. Let's try another one. Pick up the 14 and move it over. Negative 14. Y squared is equal to negative 12. Square root both sides. As soon as you put the square root on, you put a plus or minus. It has a negative on it, so an I is coming out. I mean, a negative under the square root, so an I is coming out. So I have 3 and 4, 2 and 2. So a 2 comes out and the 3 stays in. So plus or minus 2i square root of 3. So we're going to solve the radicals exactly how we solved them previously. Okay, in this one, there's nothing to move. I have to square root first. So I get x minus 2, because this will wipe this out, equals plus or minus 5. Remember, when I put a square root on, it's going to be plus or minus. I'm going to pick up this 2 and move it over. So x is equal to 2 plus or minus 5. Well, 2 plus 5 is 7, and 2 minus 5 is negative 3. Okay. Move the 24 over because the square is not by itself. Get negative 24. Square root both sides. This will disappear. And I get x plus 5 equals plus or minus an I, because the negative's coming out. 24 breaks into 6 and 4, 2 and 2, 2 and 3. So a 2 comes out and a 6 stays in. So now I have y plus 5 is equal to plus or minus 2i square root of 6. Move the 5. I always like to put it in front of the plus or minus. So negative 5 plus or minus 2i square root of 6. Remember, you have to get the square root, the square by itself. Then you would root both sides. When you root both sides, you put a plus or minus on it. Then you break down if you have a radical. Okay, completing the square to solve a quadratic. This formula is on your formula sheet. So you want to pull out your formula sheet, you want to look at it, and you want to make sure you can use it. Okay, you need to get all the variables to one side into x squared plus bx equals c. So first thing I'm going to do is move this 8 over. So I got b squared minus 2b equals 8. Now I have it in the right form. Put in this form to complete a square. Okay, so this has to go to this form. Equals 8 plus something. Okay, so put in the form, I need to take half of the middle term. Half of negative 2 is negative 1. That's what goes here. Then I need to add half of it squared to the other side. Negative 1 squared is 1. Here is the half, and I need to square it and add it to this side. It's because this is squared, this will be squared eventually. So that's why I have to square it to even out the other side. So I have x minus 1 squared equals 9. Now from this point I have two choices. I could bring the 9 back over and get x minus 1 squared minus 9 equals 0. This is the graphing form. So we could use this to graph. Right now we're doing the solving form, so I'm going to take the x minus 1 squared equals 9 and square root both sides. So this disappears, and I get x minus 1 equals plus or minus 3. Move the 1. X is equal 1 plus or minus 3. So 1 plus 3 is 4, and 1 minus 3 is negative 2. I know it seems hard, but the more you do it and look at the formula at the same time, the easier it is to be done. Okay, so let me change a color here so you can see better. I got to get it into the form where the c is on the other side. Then I split it into a squared term and what I'm going to add to the other side. So I get half of b, which is negative 4, and negative 4 squared is 16. So I have z minus 4 squared is equal to 7. I'm going to square root both sides if I'm solving it. I get z minus 4, because this disappears, equals plus or minus the square root of 7. Pick up the 4, move it over, so z is equal to 4 plus or minus the square root of 7, and I can't put that together. Now, back here at this step where I had z minus 4 squared equals 7, I could have pulled the 7 over here and got z minus 4 squared minus 7 equals 0, and then I could have used it to graph. So completing a square is for two things, graphing and solving. Right now we're solving, but we are eventually going to be graphing, so I wanted to show you that. Now, what happens in the fact that you have a leading coefficient? This is not a slide and divide. It's an actual divide. I had to divide that leading coefficient out before I can even start. So I'm going to move it up here. X squared plus 2x plus 3 halves equals 0. Now I can move this over. X squared plus 2x equals negative 3 halves. Get my x squared equals negative 3 halves plus something. Half of 2 is 1. 1 squared is 1. X plus 1 squared is equal to negative 1 half. Because negative 3 halves plus 1 is negative 1 half. Square root it. X plus 1, because this disappears, equals plus or minus I square root of 1 over 2. Now remember, we need to rationalize the denominator, so I'm going to need to separate this into the square root of 1 over the square root of 2 and multiply by the square root of 2 over the square root of 2, which will give me the square root of 2 over the square root of 4, which is 2. So now I'm at x plus 1 is equal plus or minus the square root of 2 over 2i. Move my 1. Negative 1 plus or minus square root of 2 over 2i. So we had to use a lot of our skills that we knew previously. We had to rationalize the denominator. We had to split up the radical. Had to rationalize the denominator. We had to use our I. Again, no leading coefficients, divide by 3. So m squared plus 2/3 m. I'm going to move this 7/3 over if you don't mind while we're at it, negative 7/3. M, half of 2/3 is 1/3. Squared equals negative 7/3. 1/3 squared is 1/9. M plus 1/3 squared. Negative 7/3 is the same thing as negative 21/9, and negative 21/9 plus 1/9 is negative 20/9. Square root both sides. M plus 1/3 is equal to plus or minus an I comes out. I'm going to separate these into the square root of 20 and the square root of 9. Square root of 9 is 3. So I can put the 3 here. And the square root of 20 is 2 and 10, 2 and 5. So it's 2 square root of 5. Move my 1/3 over. M is equal to negative 1/3 plus or minus 2 square root of 5 over 3i. little more complicated, but as soon as you learn the steps, it's easier to do. So we get the a and b term on the left side, we put the c on the right side. We take half of the b term and we put it in the squared quantity, and we square that and add it to the c side, and from there we solve. Practice, practice, practice. Okay, the Pythagorean theorem is used with right triangles to find a missing side. A and B are your legs, and C is your hypotenuse, which is your longest side that's opposite your right angle. A and B can be either one. It doesn't matter which you call A. You call this A and this B, but that's definitely C because it's across from the right angle. Or you can call this B and this A, and that's definitely C because it's across from the right angle. Your choice. If one leg is 5 inches and the second leg is 12 inches, what is the hypotenuse? So one is 12 and one is 5, and it doesn't matter which one you do. So a squared plus b squared equals c squared. 12 squared plus 5 squared equals c squared. 144 plus 25 equals c squared. 169 equals c squared. C, and normally when we do the square root on both sides we put plus or minus, but you can't have a minus value on a triangle, so we're going to eliminate the minus, and it'll have to be 13 plus 13, and it's inches. A lighthouse stands 162 feet tall. I'd like to draw a picture, and I'm standing 100 feet from the lighthouse. What is the distance from me to the top of the lighthouse? So I have A is 162, B is 100, C is question mark. So 162 squared plus 100 squared equals C squared. 162 squared plus 100 squared is 36,244. C squared, square root that answer. C is approximately 190.4, and let's look at the label, feet. So I'm approximately 190.4 feet away. So make sure that you just know where to put them in at. You don't always put them in at A and B. Sometimes you know C. In this case we haven't known C, but that doesn't mean that you're not going to get one like that. So make sure you look to see what you know and what you don't know, A, B, or C. Solving the quadratic equation using the quadratic formula. The quadratic equation in standard form is ax squared plus bx plus c equals 0. The quadratic formula is parentheses the quantity of negative b plus or minus the square root of the quantity of b squared minus 4ac and the quantity divided by 2a. Now, when you normally see this, and if you're saying this to Popko the Weasel at one point, you normally have parentheses in it. Just negative b plus or minus the square root of b squared minus 4ac all over 2a. Wasn't that a good singing? But here's the problem. If you put that in your calculator the way it is, it's going to come across here. It's going to do this radical, but then it's going to divide by 2, multiply by a, and then go back and add the negative b. That's not what we want to happen. We wanted to take care of the whole numerator, the whole denominator, and then divide. On top of that, we wanted to do all of this under a square root, and if this is negative, I need parentheses around it. That's why all those parentheses are in the place. If you want to do it piece by piece, that's fine. But if you're going to do it all in one, you have to have all the parentheses in. Do not add any more or take any away. They are on your formula sheet. So A is 12, B is 5, C is negative 3. So negative 5 plus or minus the square root of negative 5 squared minus 4 times 12 times negative 3 and the parentheses all over 2 times 12. And don't skip the step of you doing it on your calculator, because you have to learn how your calculator works. So I have parentheses, negative 5 plus. When it says plus or minus, you do plus the first time, minus the second time, or the opposite. The square root. Now, I open one parenthesis, so I only need one more. Negative 5 squared minus 4 times 12 times negative 3, parentheses, parentheses, divided by parentheses, 2 times 12. Now, I got a fraction, I got a decimal there. On a graphing calculator, you hit math, fraction, and it comes up that x, I moved everything. X is 1/3. Now, I need to go back and do the other half of it. And on some of your calculators, you can just hit this button and go back. But in a graphing calculator, I have to hit second enter until I see the equation come back up. Then I'm going to go back, make this a subtraction, and I get negative 0.75. I'll change that to a fraction too, because I sent the other one to a fraction. Well, this was 1/3, by the way. And I get negative 3/4. So 1/3 and negative 3/4. They're my x's. What that means is, if I graphed my quadratic at negative 3/4, it would cross, and at 1/3, it would cross, meaning that my vertex would be in between there. So it gives us a lot of information. Now, the reason I put them in fractions is because this was a repeating decimal. I don't like repeating decimals and to have to round them. If this was a decimal like 0.5 and this was 0.25, I would have kept it that way. 3p squared, I have to get everything to one side. Do not start when everything is not on one side. So a is 3, b is negative 6, c is 1. Parentheses, negative, negative 6. Now, if you just want to put plus 6, that's fine. But your calculator can handle negative, negative. Plus or minus the square root of negative 6 squared. This should have been plus 6, but it doesn't make a difference because when you square it. Negative 6 minus 4 times 3 times 1, parentheses, parentheses, all over 2 times 3. Parentheses, negative, negative 6 plus square root, parentheses, of negative 6 squared minus 4 times 3 times 1, parentheses, parentheses, divided by parentheses, 2 times 3. So I get approximately 1.82. And that will not change to a fraction. So I must use it. Gotta stop doing that. Approximately 1.82. Pull that up, hit second enter, go back and do my subtraction on that. 0.18. And notice I put the approximation signs in. Okay, next one. Have to get this 8z in, and remember we need A, B, C. So A is 4, B is negative 8, C is 1. Parentheses, negative, negative 8, plus or minus the square root of negative 8 squared minus 4 times 1, all over 2 times 4. Parentheses, negative, negative 8 plus the square root of negative 8 squared minus 4 times 1, parentheses, parentheses, divided by parentheses, 2 times 4. Negative 8 plus plus square root of negative 8 squared minus 4 times 1 all over 2 times 4. So I got approximately 1.87. Second enter, so I don't have to retype it all in, minus approximately 1.3. I mean 0.13. 4, negative 8, 1. Okay, the next one, for us to be able to do this, the first thing I have to do is get rid of the denominator. Or I need to move the 12 over, one or the other. I'm going to get rid of the denominator first. So this times this will give me this an m. This will get a 1. This will get an m. So I get 9m squared plus 4 equals 12m. Move my 12m over. 9m squared minus 12m plus 4 equals 0. A is 9, B is negative 12, C is 4. Okay, let's go. Negative 12 plus or minus the square root of negative 12 squared minus 4 times 9 times 4 parentheses all over 2 times 9. Parentheses, negative 12 plus the square root of negative 12 squared minus 4 times 9 times 4 parentheses divided by parentheses 2 times 9. Math fraction 2/3. Second enter. Let's go back and do the minus one. 2/3. So they're both 2/3. So what does that mean? Well, m is equal to 2/3 twice. What that means is if I graph this, the vertex would be sitting on 2/3. So my parabola is actually sitting on the x-axis. That's what happens when you only have one. Okay? This, it crosses twice. This, it sits on the x-axis, either opening up or down. This one opens up because it's plus in the front. Okay, so I'm going to put a 1 under these. I'm going to multiply by w, so this gets a w, this gets a 1, and this gets a w. So I have 4w squared plus 25 equals 20w. 4w squared minus 20w plus 25 equals 0. Got to get it in the form before we do a, b, and c. A is 4, b is negative 20, c is 25. In parentheses, negative 20 plus or minus the square root of negative 20 squared minus 4 times 25 parentheses all over 2 times 4. And my calculator back over here. Parentheses, negative 20 plus the square root parentheses of negative 20 parentheses squared minus 4 times 25 parentheses divided by parentheses 2 times 4. 2.5 math fraction if I want to, or I can leave it at 2.5. Okay, so 5/2 are 2.5. Second enter. Go back and do my minus. 2.5 or 5/2. So this one too sits on the axis. So w is equal to 2.5 or 5/2. Both being the same thing. Okay, A is 1, B is negative 4, C is 13. I said 12, but it's 13. Parentheses, negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 13 parentheses all over 2 times 1. Move that calculator again. Parentheses, -4 plus the square root, parentheses, of -4 squared minus 4 times 1 times 13, parentheses, divided by parentheses, 2 times 1. Uh-oh. I got a non-real answer. So one of two things happened. I either put the wrong numbers in or I made a mistake plugging my numbers in, or this does not cross on the x-axis at all, and I have to find imaginary answers, which means I have to do it by hand. The easiest way to tell, if you're not sure, if you hit go to, it'll take you back to where the mistake might occur. But I need 2 sets of parentheses there, and I have everything in the way I should. So the next step is I'm going to go to y equals, if I have a graphing calculator, and I'm going to put in x squared, instead of y squared, I'm going to do x squared, minus 4x plus 13, and I'm going to have to change that window so you can see it. I'm going to graph it. Now, notice it does not cross on the x-axis at all, which means these answers are imaginary. So I did not make a mistake. I need to do it by hand. So back I go by hand. By hand means -4 is +4, plus or minus the square root of -4 squared, 16, minus 4 times 1 times 13 is -52, all over 2. So I have 4 plus or minus the square root, 16 minus 52, -36 over 2, which is 4 plus or minus 6i over 2. Because the square root of -36 is 6i. 2 goes into 4 2 times, into 6 3 times, and into 2 1 time. So I get 2 plus or minus 3i. So if you get a mistake, most likely you have to do it by hand, but always check to make sure you didn't have something wrong that you put in the calculator. But if you go back and do it by hand and it doesn't come out as an imaginary number, then you made the mistake on the calculator. Okay, I've already talked about this a little bit, but you didn't know what it meant. Using the discriminant, that's the value underneath the square root, b squared minus 4ac, you can determine the number of solutions you're going to have. So if we go back to this one, where we did here, if I would have used a is 1, b is -4, c is 13, and I just did the b squared minus 4ac, I would have gotten 16 minus 4 times 1 times 13, which would have been -36. Okay, so I got a negative number. What a negative number tells you is if it's less than 0 or it's a negative number, there are no real solutions. It's going to be imaginary. So that way you don't have to go back and graph or go check if you had a bad answer, if you put something in incorrectly. All you have to do is do the discriminant and say, oh, it's an imaginary number. It's not crossing the x-axis, so I need to do that one by hand. If you do b squared minus 4ac and you get a positive number, you'll have 2 real answers. And if you get b squared minus 4ac and you get 0, you have 1 real answer. So let's try them. A is 1, b is -5, c is 2. Okay, so b squared minus 4ac. 25 minus 4 times 1 times 2. 25 minus 8, 17. There's going to be 2 real answers. So when you do your on your calculator, you better get 2 real answers, or when you do it by hand. B squared minus 4ac. B is 6, so it's 36, minus 4 times 9 times 1. 36 minus 36, 0. So there's going to be 1 real answer. Just like on the last page when we had 2/3, 2/3, or 2.5 and 2.5. It means it's going to be sitting on, the vertex will be sitting on the x-axis. Even with this one, we have to get them in the right position. 3p squared minus p plus 5 equals 0. Okay, so b squared, -1 squared is 1, minus 4 times 3 times 5. 1 minus 60, -59. It's a negative under square root, which is going to give us an error because these are two imaginary numbers. That means you have to do it by hand because you're going to have to pull out that I. Okay, so to solve a quadratic equations, we have four methods. We have factoring, which we did a long time ago, which was the slide and divide, GCF, grouping, difference of squares, cubics. Cubics wouldn't go with a quadratic anyway. A square root property where you get the square by itself and then you root both sides. Completing the square, which you go down through the method, you could see on the other side, take half a b, square it and add it to c, and continue. Or the quadratic formula, which I just did. So we have a choice of all of those. And sometimes I use one more than the other. Like this next one. I have negative 0.005 x squared plus 30x minus 25,000. Now, most likely I'm not going to complete the square with that. I cannot do solving a square with this because there's an x term. So my choices are factoring and the quadratic, and I guarantee out of the two of them, because of all of the decimals, I'm going to be doing the quadratic. Okay, and then you would go down and do the quadratic. On the next one, this needs to be factored first. So not factored, FOILed first before I can even decide what I want to do. And I'm going to write it twice. So I get h squared plus 4h plus 4h plus 16. And I'm going to subtract my negative 400. So I have 2h squared plus 8h minus 384 equals 0. Now at this point I can pull out a 2 and I get h squared plus 4h minus 192 equals 0. At this point I might factor it, okay, because there is no leading coefficient. So I might go 1 and 192, 2, and so forth, and I might get through with that. Or I can do this as a quadratic. I can do it as a quadratic here or here and just not do anything with that 2. It's going to come out the same. Your choice. So you have choices now, but they're the ones I would pick. Solving equations quadratic form with the substitution of u. Okay, sometimes we get into forms that are a little more complicated. For example, this is -1. You're like, what the heck is this -1? What am I supposed to do with that? So what you do is this. You go to the middle term and you make it u. So whatever the middle variable is, it's u. Then you can go back and you can make the first term u squared, which whatever coefficient it has, this is coefficient 1, you make the middle term u with whatever coefficient it has, and you leave the c. Now it doesn't look so hard, because now I can do 1 and 12, 2 and 6, 3 and 4. Subtract for 1. U plus 4, u minus 3 equals 0. U equals -4, u equals 3. Now, plug the x squared back in. X squared equals -4, x squared equals 3. Square root both sides. X is equal to plus or minus. Remember, square root has two roots. It's -4 is 2i. X is equal to plus or minus square root of 3. I don't think I would have figured it out the other way. Okay, same steps. Go to the middle term, make it u. So x minus 1. Not the 13x minus 1, just the variables u. Then you go back, and the first one with its coefficient becomes u squared. The second one with its coefficient becomes u. And then the c stays the same. I'm going to slide u squared plus 13u minus 48 equals 0. 1 and 48, 2 and 24, 3 and 16. Bingo. U plus 16, u minus 3 equals 0. Divide by 4. U plus 4 equals 0. 4u minus 3 equals 0. U is -4. U is, bring over the 3, divide by 4, 3/4. Now, plug the x minus 1 back in. Now all x minus 1 means is the reciprocal. So for me to get x, I flip it. So instead of negative 4 over 1, it's negative 1 over 4. Instead of 3 over 4, it's 4 over 3. Go to the center. I have to use u is z squared minus 5. So I can get rid of all of that because I don't want to deal with it. So this would become u squared minus 3u minus 4 equals 0. 1 and 4 are 2 and 2. U minus 4 equals 0. U plus 1 equals 0. So u is 4. U is negative 1. Now I need to take this and plug it back into both. Z squared minus 5 is 4. So z squared is 9. Square root it. Z is equal to plus or minus 3. Z squared minus 5 equals negative 1. Add 5. Z squared equals 4. Square root it. Z is equal to plus or minus 2. So plus or minus 2, plus or minus 3. Okay, let's go to the center. U will be the square root of x. So 3u squared minus 5u minus 2 equals 0. Slide. U squared minus 5u minus 6 equals 0. X minus 6, x plus 1 equals 0. Divide by 3. X minus 2 equals 0. 3x plus 1 equals 0. X is equal to 2. X is equal to negative 1/3. Square root of x equals 2. Square root of x equals negative 1/3. How do you get rid of a square root? You square it. So 2 squared is 4. And negative 1/3 times negative 1/3 is positive 1/9. So my answers are 4 and 1/9. U's are very useful. When I was growing up, I wasn't sure they were useful, but the more I go on, the more I know they are. Okay, so now it's your turn to try.